Okay, let's take a look at some SOHCAHTOA trigonometry intro notes. So, read the notes, print off the notes, whatever. Let's draw a triangle with a right angle. And let's identify an angle theta. And we want to stop putting that rounded thing. Like the rounded thing, like come on. We know what we're talking about. So, theta, as you see in the notes, is a circle with a slash through it. I'm going to draw a way better theta. Circle slash theta. It represents an angle. You can call it any Greek letter, like beta or kappa or delta or whichever. Gamma. So, remember from grade 8 Pythagoras, we know that the angle opposite of the hypotenuse is 90. So I'm going to say HYP, written out, hypotenuse. I'm going to erase that. It's very easy to identify which that one is. It's always the longest side of a right angle triangle opposite of the 90 degrees. Opposite, what does opposite mean? Opposite means opposite. So what's opposite of theta? Well, I'm going to put an arrow going from theta to the opposite side. You can't accidentally get to this side. Don't write that, because you have to curve your line. So we're going to call that opposite. I'm going to label it OPP. Now, beside theta, we have adjacent ADJ. So keep in mind, if I draw that diagram again and I call it HYP, and I choose a new letter for an angle like beta, a B with a hanging left part, well, now this is opposite and this is adjacent. Be careful with that. I'm going to read you the English instructions from the notes. The hypotenuse is the longest side, opposite of the 90-degree angle. The adjacent is the side touching the angle. And the opposite side is the opposite side of the angle. Draw an arrow to the opposite. Okay, so let's take... Oh, I'm going to do this perfectly. So if you have graph paper, do it perfectly. I'm going to see if I did my notes perfectly. I did. Okay, so let's do four squares perfectly by 3 squares perfectly. So I'm going to identify theta. I'm going to put an arrow across to the opposite. I'm going to put my right angle in. I'm going to label my hypotenuse HYP. In the future, you can start to mark stuff OA and H, but O looks like a 0, so. And my adjacent. So I'm going to give you the side lengths. So I'm going to do them in red because I don't want it to look funny, but you just do it in pencil a little bit farther away. So we have four squares on our graph paper, three squares on our graph paper. Now, if you were to measure the length of these graph paper lines and do a perfect ratio calculation, you could measure this side. Either way, it's 5. And we're going to talk about the sine ratio. Sine theta. Sine of an angle. This is called the sine ratio, not the sin ratio, the sine ratio. Gives some respect to the grandfathers whose shoulders we stand on, like Archimedes and Galileo and all those guys. So, sine theta equals, the definition of sine theta is the opposite over the hypotenuse. What on earth does that mean? Well, that gives us the ratio of how tall it is to how long the slant is. Think about that. So, some people write it as O over H, like I've done in the notes. Sine theta is equal to, so what is the opposite? Well, in the diagram, the opposite is 3, and the hypotenuse is 5. Now, some people turn that into a decimal. Sine theta equals 0.6. Those are both good answers. If someone told me I have a sine ratio of 3 over 5 or 0.6, I'm going to have a vertical of a ratio of 3 to 5. Think about it. It could be the same ratio of 6/10, etc. So that's the sine ratio. Sometimes they just ask you for what the sine ratio is. Now we can use the sine ratio to find an angle. So I'm going to rewrite the part that I'm working on. And my stuff is too big. I hope you're not writing as big as I am. I know I use 4 squares for that 4 squares over there. I'm sorry. So we're going to find theta. So theta equals. So sine theta is a function. It allows you to put thetas into it and figure out what the sine ratio is if we do backwards what we just did. Either way, down the page, sine -1. That is the inverse calculation. What it does is it allows us to put a fraction or a decimal. I'm going to erase it for anyone who gets confused. No, I'm going to rewrite it. 3/5 theta equals sine -1 open bracket 0.6. They're the same. It gives us theta. So make sure your calculator is in degree mode. If you buy a graphing calculator, it's in radian mode. And for anyone who does grade 11 math with this thing, they fail their first test. So degree mode, and we get 36.9 degrees. Fun. I'm going to put an arrow to where that belongs. Okay, what does this mean? Oh, cool. We can do calculations with our calculator. So we can sine things and we can second sine things. So if you were to second sine 0.6, you get 36.9. Pressing the shift or second and then the sine button. That allows you to get the angle. What fun. So what is this? I'm going to shrink it vertically this time. I hope you're writing smaller than I am and have smaller graph paper, whichever. So now I'm going to talk about the rest of SOHCAHTOA. So SOHCAHTOA, as you can see in the notes, I've written it all out. Sine is opposite over hypotenuse, O over H. Cos, sine we just did above. Cos is adjacent over hypotenuse. So if I wanted to do the cos ratio, cos theta would be the adjacent. And of the diagram above, the adjacent is 4, and the hypotenuse is 5. So they might ask for a cos ratio. And you can give them the decimal like I have in the notes. And what's that last part of TOA? Tan. Tan theta. Tan theta equals... Ooh, I didn't write the formula for cos. I'm going to do that directly below. Cos theta equals ADJ over HYP. Always write the formulas down. Then substitute. So switch those if you want, as it says properly in the notes, whatever. So now we're off to the right at tan theta. Again, the last part of SOHCAHTOA. And tan is TOA. Whoa, look at TOA above. That looks like an H. It should be an A. I just corrected this to say TOA with an A perfectly. Notice my letters get funny. Be careful with your printing. My apologies. The title above SOHCAHTOA is correct. SOHCAHTOA. So following tan theta is TOA. So that's opposite OPP over adjacent ADJ. TOA. Tan is opposite over adjacent. That's a formula. I put boxes around my formulas and I circle answers. Therefore, tan theta is opposite of the triangle above, 3. Adjacent of the triangle above, 4. And as you can see in the notes, I found the angle with both cos and tan. Obviously. Now I'm going to read an English sentence. I'm going to show a scribble in its place. Choose the part of SOHCAHTOA that has two pieces of information that you want, and that we have, and one that we want. I messed that up. I'm going to do it again. Choose the part of SOHCAHTOA that has two pieces of info that we have, and one that we want. And always measure the diagram after with a protractor and make sure that it all works. Or make up your own and find stuff and use a protractor and a ruler to see and just be blown away at how cool this stuff is. So remember, sine, cosine, tangent, SOHCAHTOA they are functions that allow us to perform the reverse process to get the angle. Okay.